Right, so the purpose of the screencast is to explain a lot of documentation for the second CA for a multiplayer game. So there's a lot of networking questions that I have to answer from as a requirement to submission, and just to explain, and I highlight what's the my contribution to the game in general. So at the start, I just want to talk about the what changed from the previous CA. Now, on my situation, I there's a significant difference from the first CA and second CA because I changed teammates. So I was teaming with Connor at the first CA, and then now I'm teaming with Josh. And then me and Josh was having a discussion to use his first CA as a base game to work out in as a multiplayer game. Now, just a quick reminder of I cannot show you here because it's really hard to get the first CA on my local, but I just want to remind quick reminder that the first CA of on Josh's side is two ships with three islands that can just rotate at its center point and move into direction of that ship orientation, and then this ship's able to shoot bullets wherever the ship is facing, the direction of facing it. So uh, now we decided to change the theme, so we are kind of go back more a bit like uh, ancient Tyrene and stuff like that, and then we're sort of the other two sprite ship on the game is like a frigate and a pirate frigate, but yeah, it's not losing the um, older era of like and then we are redesigning the game into like a instead of like 1v1 battleship into more of like a battle royale colosseum thing. So we heard that on the ancient Rome era they used to float the actual colosseum and then um, put ships on it to mock have like a mock naval battle. So that's where the idea came from, and then I can show you the how the overall game works now. No, so this is the host, and then this is the client. No, the host here has the power to. So maybe just gonna mute the just gonna mute the sound a little bit. So um, so the host has the power. So this is what I call a pseudo lobby state. So we are in the game, but the game will not actually start. Like the timer and everything is not gonna start until the host press enter the game, and then everyone can move. So if the host press enter, and then we can move around, and then you can see it's kind of synchronized. The frame rate here is a bit dropped when you are out of focus of the window. You can see now I'm focusing on this window. It's like around the yeah, so you can see like it's a bit draggy here when you're not focusing, and then you can traverse the world, and then now you can shoot from right to the left of the ships. So it's kind of giving a little bit more difficulty. So like you cannot just shoot blindly wherever it is facing your front. So it's kind of interesting, and then of course the specialty is if you hit any of the blocks, you're just gonna go kaboom and die. No. Um, so that is the premises of the game. Then now I can talk to my contribution, especially for the game. So the first thing I did is uh, implementing the lobby state that I talked previously. So the lobby state here, as I mentioned, is not a real lobby state. It's not a different class called lobby state that is, you know, inherits from a state and whatsoever. But it's just the way it works. It's a simple F check. So I have yeah. So in the client, I have a boolean called mlobby state, and then when the client is initiated, I always say it's the lobby state is true, and on the update, I can say okay if it's not on the lobby state, you can handle the real-time input. So basically, there's no real-time input getting handled if you are on the lobby state. Hence, explain why you are not able to um, move move or shoot during the lobby state. Now, um, so I kind of set the player invitation into saying press enter to start the game. Now I just want this into showing when you're the host, because the host is the one that have the power to start the game. So in the draw, I have an extra F there. If it's in the lobby state, and you are a host, then draw the player invitation game. Now this check is just simply to make it blanking. And now the power for um, host to start the lobby. Now, so you see from the base code that we get from the class that this event key press here and then say return would have a request co-op partner, which is spawning a local bucket. Now I feel like in our game it's not really making any sense. Well, you could, but like I decided to just have one player for each. Sorry, one ship for each player, so it's really easy to see who's the winner and who's the winner in the end. So I decided to change that into okay, if I press enter and I am the host, and then I am on the lobby state. So this press enter will only work on the lobby state while the lobby state is true, and then if the client itself is the host, it will send the server a network protocol packet, a packet type request start game. Now this is a new network protocol, so request start game doesn't really take any parameter. It just tell okay, the host wants to start the game. Now in the game server, let's see how it's handled. Packets request start game. Yeah. So here you see it listens to the packet type request start game, and then now after it listens, it's immediately creating the packet and then gonna send server type packet start game to basically just to notify the other client, okay, you start the game. And then similar to the server, I have also lobby state. So this lobby state on the server is to prevent the timer to being ticked down. So basically, there's a lot of the server that I want to freeze over as well on the game server, so we can check the final reference here. It's just making the things quicker. So that is setting, yeah, and then so this is checking the winner. So basically, don't set the winner to always false if you're in the lobby state, in case you only have like one person in the lobby. So we don't want it to be a winner. Yeah, this is checking to as like another game over statement. So if your game timer is up and then you're not in the lobby state, you can end the game. So this is the line we just visited, and then yeah, so here is a bit important. So this mlobby state is really important here because if this means that it's only accepting player connecting into that game when it's a lobby state. So when all people are moving around shooting and stuff like that, if there's someone trying to connect to the game, it would just say could not connect to the server because I shut down the listening state, or rather they cannot access this block of code here because I have the mlobby state into false. So basically that's what the mlobby state purpose is. Moreover, so to check the conditions, a lot of the conditions that is relying whether it's checking whether you're on the lobby state or not, and then the most important is to recheck player coming in while it's not on the lobby state. So it's really handy because the way we have our game works, if you could just keep connecting to the game, and then like eventually, you know, no one would win, just like endlessly loop of people joining in. Well, the only way you can win is just like people stop joining in. But like, yeah, so I say m clock restart here. So m clock here is taking for the actual. So we have the so this is for the timer purposes. I can explain that later. And then of course the listening state into false. So basically just reject incoming connection from the clients if the game's already started. So that is the lobby state and its restriction for player connection and stuff like that. So now we can go ahead and talk about timer. No, timer. So timer here, I'm just having a tax. So basically saying, okay, so I have the actual timer, of course, and then I get the minutes of the timer, and then the second of the timer, and then displaying that as a text. So the timer itself will not count down. So the synchronization that I have for the timer is just when it started, and that's it. So when the M lobby and then we know that the timer will start when the lobby is started. So I just use that start game notification to handle packet. Just a second. Start game. Yeah. So you see in the start game I just set the lobby into false and then M clock to restart. Now the M clock restart here is just saying, okay, so in the update here, so no, sorry, oh sorry, it's on the yeah, so I'm start now, and start restart there on the client. That is just for printing purposes. So it's client doesn't really do check whether okay my clock is done, so the game should be done. So the one that actually doing the check is on the game server. So saying if now is more or equal than the game timer, which is I send to 900 seconds, which is 15 minutes, and then it's not in the lobby state, send the game over packet to all of the clients. Yeah. So the only synchronization to time is a bit dangerous, but we can limit the data that we are sending over for per text. So the now the chat the synchronization is only done when we switch over from lobby state into the game state. So we just set that M clock to restart. So and then actually ticking when it's not on the lobby state. So it seems the timer to be working well, although it's a bit dangerous when you only have like 1 FPS or 2 FPS, just like the demo in this afternoon. That would be an interesting situation, but for now I think it's just necessary if it's you know, server just doing the checks and then just send a game over packet when the server clock is ending. Now the next one is a bit interesting, so it's spawn point. So I have a custom struct on the game server. Just go there. So it's called spawn point. So spawn point just store the position, rotation, and ship identifier. So basically it's just data set that just have a okay. This is the position, rotation, and then what ship is spawn into that. Now, so that's just intelligence being, yeah, and then so in here I just have a bunch of spawn point with basically 13 spawn point, which is basically saying this is the width 6. So I specify like, okay, in this point of the map, and then you have a rotation of 90, and then -1 is when the spawn point is actually free. So this -1 is just a pre-holder for, like, sorry, it's an indicator when a spawn point is actually free or not. So in the spawn self on the server, so when player are connected and then we want to tell, okay, spawn yourself. So it's here, yeah. So so in here I say while it's true, check the random number from 0 to 12. So because I have a index, so I put all of the spawn points into a factor, and then now spawn the factor into a random number of the index of the spawn points, and then you get that position rotation for that spawn point. And then I need to set that spawn point to have an identifier of what the respective ship identifier. Now, this is important because when player are disconnected, so we can say, so when we handle disconnected, before we delete the ships, we can say, okay, get that, okay, go through all the spawn lists, and then check, oh yeah, this is the ship identifier that I want to delete, and then just put that into -1. So I do this just because if we were planning to have a um, respawn feature, so if people are disconnected and then, like, well, this is originally because the game allows you to join when to join when it's not on the lobby state. So I think now it's kind of a bit pointless to have this, but it's nice to keep anyway, because if we develop feature like the respawn that I was going to talk about, we might need something like this. It's just basically free up the spawn list, the spawn points that we can use. So that is one point. Now we can talk about synchronization. So in the update client state, so everything I send not only just position and just the position, but I also send the position, X, Y, rotation, and head points. Now the rotation itself, it's a must, because you need to sync across how the ships are rotated and stuff like that, in order to they just not strafing with the straight rotation and stuff like that. Now the head points is really necessary, because I think there's a relation in this on why this is being a TCP, and then the update is not as often as I wanted to. So when a ship is get blown up via getting hit a block of cover or like obstacle there, um, the instance is usually on the other clients. The other clients is that ship will stop moving just right before it hits. If I just sync the position and rotation and then not hit points, so the while in my client the ship will destroy it because it hits the block, the on the other client, my ship that is networkly handled there will stop right before hitting the block, because in the last update they did not detect any position update. So that's why the death is slightly so it will cause a desync. Well, the ship will not moving at all, because I have the actual player have no control in it, but it's still there. So I think syncing with the hit points prevent that. So it's just, okay, if that guy dies and then have a hit point 0, then you can destroy that as well. Now, let's see how we handle that. Drop the play in here. So basically, it's reading all of the position, it's reading all of the reading all of the position, X, Y, rotation, and hit points, and then saying if it's not local, then set the position, set the rotation, and set the hit points, and then have a check if the hit points are bigger than 0, just set it, and then if it's less than 0, just destroy it. Now, this check also helps to avoid the debugging error when you're trying to set a hit points bigger than 0. So yeah, so it's a bit more expensive because every tick you're sending an extra let's see what an extra SF-AIM32, which is 4 bytes. So that is an extra 4 bytes for every player, every tick, which is quite expensive, to be honest. But I feel like that is quite necessary just to have a good, really good synchronization. Now, there's a custom feature that is called a sprite. Well, I call it sprite settings, so I can show you here real quick. So in the settings, there's a button right there called change ship. So if you can see, currently it's set to frigate. So I can change it into ship, I can change it into pirate. So I change it into ship for now, and then show you in the game that now my sprite is a ship. Now, the neat thing about this is if I exit the game and then run that again, if I didn't change any of the settings and then go to host, it should save my settings that my sprite is a ship instead of a frigate. Now, this is the form of the game persistence that we have currently in the game. So I can explain. So in the setting state here, we have the interface. So we having the interface saying, okay, so the sprite will loop through every time you press this sprite. You will add the texture ID by 1, and then you can see the texture ID is structured as such. So it will start from here, 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 and then go back in here because the mathematical modulus plus the starting position. So so that kind of the functionality of the interface, and then we have kind of a bit like a translation. So if my texture ID is shift forward, get the level to shape, frigate, and so on. Now, how to implement this actually on the local, on the multiplayer is quite tricky. So, yeah. So, so basically, how its structure is. So after you spawn self to any of it, and then you get the texture from the file. So basically, I have a file here on that is just called ship texture. Ship texture is basically saying that, you know, if it's a ship, then that will give me the ship tracks sprite. If it's a frigate, they will give me the frigate, and so on. Now, so every time a spawn self is getting called, and then the client will send the server on what texture that ship should be, because on the spawn self, I can just set the texture easily on the client, but I need to notify that into everyone else as well. Now, this is where I'm not sure if this is the best approach to do it, but currently it works fine for this scope. So let's see. So in the server, it listens into what type of texture what it wants, and then what the ship identifier that should have that texture. Now in the ship info, we have the info of that texture, so I just set that, and then it will loop through all of the ship info and make sure that all of the client have the right texture for every ship. So that's why there's gonna be a slight delay when you're connecting as a 13 player or something like that. If you see someone connecting as the last player, there's like, okay, oh, I see the default one, which is the ship texture, and then after that, after like 0.5 second, it will change to whatever the texture meant to be. Now that is the drawback of this methods. So it's gonna have a delay before it's actually spawning the texture, but then it does actually getting whatever it's on their respective files. Now, on how do I read the file? And so basically I have like a translation here from, so get from texture file, basically saying if it's got ship, return the texture ID respectively, frigate and pirate, and then same vice versa. So if I this is get called when I set it on the interface on the settings thing. So basically if I press back, and then this is what happens. So I just write, okay, if the current texture ID is straightforward, just write ship, frigate, and pirate, and so on. So that is the game persistence and the sprite settings that we have right now. So it's a nice thing to have kind of distinction on the player hands on how they should look in the game, and then that is as of one of the form of the game persistence as well. So it's quite nice, even though it's not working. I don't believe this is the most effective way to do it, but at this scope it is somewhat acceptable. Now there's two last things that I need to mention that I did on the multiplayer state. Is the first one is prevent the host to exit the game when he dies. Well, basically, I actually prevent all of the clients to exit the game before it dies. When the player dies, so you're only able to exit the game through escape and then return to the game, or when the game is actually finished. Because I don't want we don't well sorry we don't want a situation where the game someone's just able to kill the host and then the whole game just end, because the host is like uh, is sorry it's not available in the game anymore. So I just get rid of the if there's no local ships and then the game is started, game over. So we just get rid of that, and then basically the only way you can end the game is when there's no player in the game anymore, which is quite unlikely, or you have a game notification from the game server, a game over notification from the game server dies. You're the last person standing. Now, transition into that, so the game server will check everything. So let's see. Yeah, so every take if there is a winner or not. So basically, you will have a winner when the shipment there is only one last ship standing on the game, and it's not on the lobby state. And then you will try to get what ship is that, what ship identifier is that, and then you will send everyone a game over packet with the identifier there. So, and in the client. Yeah, in the client, oops. In the client, when you listen in the game over, it reads the identifier and then searches if that identifier is the local ships or not. And then if it's the local ship, then set the screen into winning. And then if it's not, then you're game over, you lose or something. So that is the win condition and all of my contribution to the current CA. Now, I'm going to talk about. So after doing some calculation, the bandwidth limit or the bandwidth requirement for bits per second that we are sending in our game is quite high. So we the way we got the number is 757 and 120 bits per second. So that is like 757 kilobytes per second, almost like 1 mega almost. So why is that? Is because a lot of this. This is the calculation that we how we achieve this number. So there's 13 players in the game, and then per player, the biggest number that you can send over across is 28 bytes, which is pretty big, and then multiply that by 8 because it's bytes, and then the tick rate is 20. So that is a 757,120. Now, if we are asked how we can reduce this is from this number, because if you can see in the code, this is the biggest packet that you can send. A lot of this still using SF-32, which is arguably this could be UN8. This could be UN8 as well, saying that we only gonna have 13 player maximum, and also 13 ship because there's no double ship each player. Same with the identifier. So the float can stay as a float because we need them as a float. So still gonna be four bytes each. Rotation is gonna be still the float as a 4 bytes, and hit points should be a UN8 as well, because the maximum of hit points that we gonna have is like 100. Well, maybe not a UN, maybe just an in8, because there's some cases where hit points could be minus when you get overkill. But still, that is, so you can reduce that into this 1 byte, so that's 2, 3 byte can stay this 4, so 7, 11, 15, and then this could be 16 byte now. So we have 16 byte that is considerably reduced from the 28. So, now the reason we didn't do this, because it's simply because we don't have enough time. There was an issue when we tried to have a optimized package in just one site, so we decided to have like an M identifier for a player that is a UN8 type, but we forget to set all of the listening, anything that is listened to that packet type, to that packet type into UN8 as well. So that's why we focus into developing the features, optimize, and then we're planning to have an optimization in the end, but so it's just simply running out of time. Now, the last thing I want to discuss is how TCP affected the implementation. So I feel like the TCP here is kind of reducing the rate of the synchronization. So how many ticks, how many packet sending that we can do. But so for example, there's an issue that I mentioned earlier with why I need to sync the head points as opposed just to sync the position update, because there is a 100% chance they're going to be desync when the ship position is moving into a box, or like an obstacle that are going to let them explode, while the TCP is a bit slower. So that's why the last position update that actually made the ship destroy goes into the box and destroy. It's not getting notified across the network. So if that were UTP, and then I think there's a lot of the update client here could be significantly decreased. Well, it could be decreased by 1 byte potentially, because we're not gonna syncing the head points and then just simply call them more often, so it have more precise synchronization with the position. Now there's a lot of things as well, like the timer could be desync and stuff like that. But yeah, basically the TCP would have would kind of prevent a more tick rate. So because it's quite expensive to have more tick rate in the TCP rather than UDP. But yeah, I think that's how the TCP affected the implementation. So basically, this is the main biggest thing I have to say with the head points, because it's a TCP. My theory is that if you're switching over UDP and then we can increase the tick rate, we do not need to sync the head points any longer. But that is my theory. So that's it for all of the screencasts that I anything, everything that I need to talk in the screencast. Um, so I hope everything makes sense. Thank you very much.